A parent function is the most basic function in a family. The parent function for a constant function is f of x equals to 1, where y equals to 1. The parent function of a linear function is f of x equals to x, where y can be all real numbers. The parent function for an absolute value function is f of x equals to the absolute value of x, where y is greater than or equal to 0. The parent function of a quadratic function is f of x equals to x squared, where y is greater than or equal to 0. A transformation changes the orientation, size, shape, or position of a graph. There are several types of transformations. One is a translation. A translation shifts the graph horizontally or vertically. For horizontal translations, the function of f of x minus h is used when h is not equal to 0. When h is less than 0, the graph is shifted left. When h is greater than 0, the graph is shifted right. For vertical translations, the function f of x plus k is used when k is not equal to 0. When k is less than 0, the graph is shifted down. When k is greater than 0, the graph is shifted up. Another type of transformation is a reflection. A reflection flips the graphs over a line called line of reflection. Reflections of the x-axis multiply outputs or y values by -1. Reflections over the y-axis multiply inputs or x values by -1. There are two types of stretches and shrinks, horizontal and vertical. Horizontal stretches and shrinks multiply inputs by the variable a, which stretches or shrinks the graph by a factor of 1 over a. The function of a horizontal stretch or shrink is y equals f of a times x. When a is between 0 and 1, it is a horizontal stretch, which moves it away from the y-axis. If a is greater than 1, it is a horizontal shrink, which moves it away from the y-axis. Vertical stretches and shrinks multiply outputs by the variable a, which stretches or shrinks the graph by a factor of a. If a is greater than 1, then it is a vertical stretch, which moves it away from the y-axis. If a is between 0 and 1, it is a vertical shrink, which moves it toward the x-axis. When given a slope represented by m and a y-intercept represented by b, use slope-intercept form, or y equals mx plus b, to write the linear equation. When given a slope represented by m and a point represented by the coordinates x and y, use point-slope form, or y minus y sub 1 equals m times the quantity x minus x sub 1 to write the linear equation. When given a point represented by the coordinates of x and y and another point represented by the coordinates of x sub 1 and y sub 1, use the slope formula, or y equals mx plus b, to find the slope, or m. Then use the point slope form, or y minus y sub 1 equals m times the quantity x minus x sub 1 to write the linear equation. The line of best fit is a straight line drawn down the center of a group of data points. Finding the line of best fit is simple. First, make a scatter plot of your data. Second, draw a line closest to your data points. Finally, using the 2 points on your line, write an equation of the line. Linear equations in 3 variables, or x, y, and z, are written in the form ax plus by plus cz equals d. Systems of linear equations are like the one shown here, with multiple equations that all share the same item, x, y, and z values. To find the solution, find the order paired triple, or x, y, and z, that fits all 3 equations. First, rewrite the solution with 2 variables using substitution and elimination. Next, solve your new linear system for both variables. Finally, use substitution and substitute one of the values from your previous step into one of the original equations and solve for the variable. Thank you for watching the video.